Hi and welcome to video 12 on this series on reducing balance loans, which is a component of the loans, investments and annuities topic in Unit 4, Topic 1 of the General Mathematics curriculum. We're going to talk about the recursive model today, which follows on from our previous video on general reducing balance loans and how we can use a spreadsheet to calculate them. So the textbook gives us this, and I'm going to talk through this. Basically, the recursive model, if you look at the spreadsheet from last lesson, is a what I will still owe next year is equal to what I owed last year, or what I owe this year, sorry, times by the rate, which is 1 plus I, minus R, my repayment. And I'll set up, so R is the repayment here, based on the compounding period, whatever that is. I is the decimal interest rate per compounding period. So if it's monthly, you have to divide a yearly rate by 12. And then we've got this N is the number of compounding periods, but that's just to do with AN. So if I want to know what I'll owe after 10 years, I get the what I owe after 9 years. I multiply it by 1.01 and I subtract R. If you watched the last video, it's also what I was doing in that video. And for the case in the last video, the next year's value is equal to this year's value times 1.08 minus 1200. And that's our formula. And it's on the formula sheet. So that's good. We like it when it's on the formula sheet. Of course, the formula sheet has an R, not an I, but they mean the same thing. So just be careful with that. This R here is also in the textbook, and they're saying that R is equal to 1 plus I. So I is 8%, which is 0.08 here, and then the actual rate is 1 plus I. So just make sure that you get that right. So let's have a look at a couple of examples. Alicia is repaying a $2,000 loan at the rate of 6.5% per annum compounded monthly. How much does she still owe after half a year if she can afford $250 per month? So this is a table type question. I've got to build up half a year, it's per month, but I need to know how much she still owes after half a year. So I'm trying to work out A6. A6 being the value after half a year. So it's going to be a bit of build up here because I know that A1 is equal to $2,000 times by the interest rate. Keep in mind the interest rate is yearly, so I have to change it into monthly. I get the percentage amount, I divide it by 100 to make it a decimal, and by 12 to make it into a monthly rate. But of course I need R, not I. So that's my I. I'm going to move this to the side and be a bit clever. It needs to be 1 plus that to get my R value. And then I subtract my repayment from that 250. Now, in the past, with compound interest, we just whack a 6 up here and we'd be done with it. But it's not the case anymore, because now the problem is that we're repaying each time as well. So it's just that level trickier. But I'm going to do this calculation, and I'm going to set up a recursion model on my calculator again. So I do 2000 equals, and then I multiply that by the whole lot, which is 1 plus 6.5 divided by 1200. And then subtract 250, and so A1 is equal to 1760.83, and that means that A2 is equal to 2000 times A1, sorry, not 2000, it's equal to A1, which is 1760.83, times by 1 plus 6.5 over 1200 minus 250. Now I've got my calculator set up, I press enter, and that gives me 1520.37. It might be worth pausing the video and just checking you get the same answers as me. Now A3 is my next term, and I've just pressed equals this time. I'm not going to write it down every time. And so equals gives me 1278.61, and I could obviously put that into the formula each time. A4 is equal to 1035.53. A5 is equal to 791.14, and A6 is equal to 545.43. So after 6 months, and I've got to be careful here and just make sure that it is indeed after 6 months, A1 was starting at A0 right at the start with one period, so that's the end of 1 month. So this is indeed the end of 6 months. Just make sure that you don't have any time correlation issues. At the end of 6 months, she still owes $545.43. I could do that on a spreadsheet, but if this was an exam, you'd be depending on recursion in your calculator. But later on, we're also going to introduce a formula that would help you with this as well. And a second example, this one's a bit trickier. Corey has a $5,931 credit card debt. He can afford to pay it off at $400 per month. He has two options. He can either continue to repay his credit card at $400 per month, given the provided rate of $16.99 per annum compounded monthly, or he can refinance to a personal bank loan with an interest rate of 9% per annum compounded yearly. Assess Corey's options by considering the time it will take to pay off his debt in each option. Justify the reasonableness of your result. So we're going to do this calculation now. But again, I'm going to assess the question first, particularly as it's a non-exam situation, and think, how are we going to do this? We want to know which one will pay off quickest, and both of them involve regular repayments. We suspect that this one will be quicker, option 2, because it's a lower rate, so it should be, but we need to check it, and that's what the question is asking us to do. Assess means we need to go through the mathematics as well. So $5,931 at $400 per month. Now if I divide $5,931 by 400, that's at least 15 iterations. So because it's at least 15 iterations, I'm not going to set up a big table. What I'll do is I'll do it on my calculator first, and I'll show you the setup for this. So the setup is, for option 1, it's going to be 593, that's not a 3, 31 equals, and then it's going to be answer times by 1 plus 16.99, but it's monthly, so divided by 12 times 100, 1200, minus his repayment of 400. I'm going to press that heaps of time until we run out. What I will do is I'll press it heaps of times until we get to a number under 400, and then I'll add the interest on one more time and see what he owes in that last month as well, because it's going to be close potentially. So I start with the 5931 equals, then I multiply that by 1 plus fraction bar 16.99. Don't like decimals and fractions, but these questions you'll see it a lot. Close brackets minus 400 and press enter, and that's the first time, and I get $5,614.97, just so you can check that you got the same thing. So this is 1 month, and then I've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16, and now he owes 300.47. I'm going to get that. I'm going to multiply it by one iteration of that interest, 1 plus 16.99 divided by 1200, to add interest on. Now that goes to plus interest. He now owes $304.73, and now that I've added on an interest, that's his last repayment. So he has to add on, so he has to pay off 16 times and then pay off one more time at 304. Option 2 is going to be to do this again, but this time with a 9% rate. So the same thing, it's going to be 5931 equals, and then it's going to be answer times 1 plus 9 over 1200, and then minus 400. So I'll do that, and I'll write the full answer down and then bring it back. So this time, after 15 months, he now owes $308.96. I multiply this by one more iteration of the interest, 1 plus 9 over 1200, and that becomes $311.27. So he owes $311.27. And that would be his final payment. But this one took 15 months, this one took 16 months with quite a similar final payment. which means he's out of pocket. There's $7 more in his final payment, but it's 1 month early, so he's out of pocket about $393 if he takes option 1 over the period of about not quite a year and a half. So that's an important feature. We could do this in a spreadsheet as well, which I'll let you play with or talk to me in class if you need to, but otherwise I might leave it there for this video and those 2 examples. All the best.